mobile collaboration was featured in the new scientific magazine. He has also participated in various standardization efforts. Recently, he contributed to the Universal Plug and Play Quality of Service Working Group efforts as a co-author for QoS v3 standards. All right. Thank you, Puneet, for accepting our invitation.
Yeah, thank you.
And with this, okay. So we want to ask your questions after the presentation. I'm gonna pass on the microphone.
Thank you, and thank you for all for being here. And,
Yeah, it's right there.
You want to use this one, or you want to use?
Okay.
Use this.
I'll probably use this because I tend to walk.
Okay.
Can you guys hear me?
Yeah, Jeff told me.
Excellent. I had good breakfast, so I can't swallow it yet, but I will try my best. So I think what I'm going to talk about today is IT for sustainability and how HPE and Hewlett Packard Labs are innovating and contributing. Also the various sustainability initiatives that Hewlett Packard Enterprise has, and then move into what Labs is doing, what various projects that we are in IT for sustainability in this space, and then of course finish with some concluding remarks. So in IEEE Future Directions Committee, my esteemed colleague Behnam has been working on trends and mega trends. So I thought I will actually sort of share what was predicted and how sustainability and IT actually match in this. And these trends and mega trends are related to IT and computers and such. So before actually going to what was done for 2022, I thought it would be interesting to actually score their predictions from last year as well. And given the pandemic and things, actually some of the interesting trends they were predicting was about remote workforce technologies. We have been doing the presentation on Zoom. A lot of that has actually done really well. Similarly, sort of more in-memory computing and social distancing technologies were predicted. And so in general, I think the team that they are of experts that Dejan has and works with did a tremendous job of predicting the trends for 2021 really well, right? So what about 2022? In the beginning of the year, they actually sort of talked to their expert panel, and in terms of various sort of domains from core technologies where NFTs and such are there, all the way up to various productivity tools like low code, no code, metaverse. Similarly, range of technologies related to pandemic and healthcare, where remote medicine and 3D printing were. So these are some of the 16 technologies that were predicted to be the trends for 2022. And in there, actually, what they also did was to talk to the experts about the desirability versus the likelihood of that technology to become mature, right? And ideally, what you would like is that these trends are highly desirable, also are more likelihood. So people, what they desire are actually sort of working on the technologies there as well. And I think interesting thing like remote medicine, right? Again, pandemic and the healthcare convergence of HPC, AI, and things. Sort of they fall interestingly along the likelihood desirability metric, but then there were also things like NFTs, where the desirability seems to be pretty low. I don't know what the feeling in the room is with respect to who all wants NFTs to be really popular. I see a few thumbs down. All right. I guess we match. And then there are also actually things like trustworthy AI, because AI is actually being incorporated in a lot of the things that we are doing to drive a lot of the control loops and things. So how to make that trustworthy. Janice yesterday talked about the data analytics and how you can use it for various causes, whether they are agriculture or healthcare. So a lot of that data actually becomes interesting as well. So just wanted to, so these were the trends that were predicted for 2022. And then sort of, if you think about these individual trends that you are seeing for 1 year, mega trends that the IEEE Futures Directions Committee is trying to actually look at is, if you took multiple of these trends over multiple years, which have multiple factors that you want to impact, not just the technology, but also the something relevant to this conference, the economical factors or the social factors and so forth, right? So what are these mega trends that will actually do it? And it's not something that is temporarily fashionable, right? We saw thumbs down for a lot of NFT stuff that seems more fashionable, at least right now. And so on. So I think what you can actually do there. So what was done was to actually look at the grand challenges, right? If you want to look at mega trends, whether it is hunger, poverty, climate change, and so on, and then move internally as to what can the technology be used and applied to when you are trying to solve or tackle some of these grand challenges. So for example, quantum computing, even cyber assurance, and so on, is these interesting technologies within the application areas of the technology for solving these grand challenges. Based on that, the committee basically came up with 3 mega trends: digital transformation, sustainability, and then what is called virtualize everything or simulate everything. You can actually think of everything from metaverse to digital twins, whether it is for manufacturing or data centers or energy management itself. So that is what there was. So if you sort of, but when you put that in terms of how they will align with the adoption, the S adoption curve that most of you are familiar with, digital transformation actually is fairly mature. And then if you actually sort of start looking at sustainability, that is getting a lot of traction is coming on in terms of how IT is being applied there. And then the virtualize everything is sort of behind in terms of the maturity of on the S curve itself. But then if you think of it, the digital transformation itself has sphere of influence. And then similarly, sustainability and how, if you had sort of simulating everything and digital twins, what would that impact be, and so on. So in terms of how the trends and mega trends, because we were discussing earlier about the IEEE initiatives and what can actually happen, you can see how the tech trends lead to the mega trends that we were discussing, and then the FTC initiatives leading to some of the roadmaps coming out of these initiatives in the community itself. So for example, with virtual worlds, the impact is a lot on economics and the social aspects of things. There are multiple technologies like AI, software, hardware, amount of sensing that needs to be done, and different IEEE societies from Computer Society, ComSoc, and the implemented. And then there were basically sort of other FDC initiatives that come out of that in terms of IEEE telepresence, the blockchain, digital privacy, and such. Right. Similarly, you can go with the energy sustainability. We were talking about IEEE smart cities effort and smart village earlier. So a lot of these things basically fall in there. And for digital transformation itself, earlier work on cloud computing or software-defined network are some of the initiatives that have come up. If you are interested in these predictions, actually the IEEE computer has now a predictions column. The first column in October 2021, when this was started, actually did get the most downloaded award. And then the July 2022 issue has more details on the mega trends if you are interested in going and reading about it. So I'm going to actually sort of change gears from trends and mega trends and focus more on sustainability, because that's what I like to talk about, and give you a view on how Hewlett Packard Enterprise is actually sort of working on sustainability related issues. So we actually are accelerating the net zero impact, and just earlier this year announced that from instead of going net zero by 2050, we are going to sort of reduce that and put 2040 as the target by where HPE actually goes net zero. By 2030, we want the operations to be 100% sourced by renewable energy. 85% of the equipment which is returned to HPE is upcycled and put back. And then actually not just we are sort of internally making our operations and the whole supply chain and products more sustainable, we are also actually contributing to the IP portfolio for the transformation of low carbon technologies, and 6,000 plus patents have been filed in this space. And then we are working with our suppliers to more doing the audits in terms of the social and environment responsibility as well. So some of you might actually sort of think about, look, a large corporation like HPE, what their carbon footprint is. And I think in 2020, our carbon footprint was 7.8 million metric tons of CO2 equivalent. To give you a sense of what that means, this is about 1.7 million cars on average on the road in a year, right? So that's what it was. But if you split that further, 27% of that carbon footprint actually comes from our supply chain, and 68% from how the upstream companies are actually using the downstream consumption of the HPE product itself, right? So 90% of the greenhouse emissions is attributed to manufacture and use. So we are actually as far as our enterprise operations and things are concerned, we are actually fairly lean and mean. So if you think about what we are trying to do with respect to making HPE more sustainable and interesting, a lot of it actually falls into how do you make IT enterprises more efficient by doing what I call workload optimization, right? So I will talk about some of the broader capacity supercomputers and things like that. But in general, if you have IT infrastructure, you can reduce the energy usage by running them at the highest level of the operational capacity or increasing the utilization. Similarly, if you can improve the energy efficiency, I will give you some examples for amount of the energy required for doing the compute. And then these data centers and these facilities don't run by themselves. There are the support equipment and cooling and so on, even personnel who actually sort of manage these things. The better you can improve that resource efficiency, better it will be. And also the software that runs on these, if you can make them efficient, can with intelligent management can improve. So here is sort of the one slide or one message that I want all of you to sort of take with you about when we talk about sustainability and IT for sustainability. There is a lot of work that you need to do to be able to control these infrastructure and IT that there is. But key to that controllability is how much you are able to observe and get the data and metrics to be able to make smart control decisions, to be able to making them more resource efficient, increasing the utilization, being able to add value to it and such, right? So talking of observability, one of the proof of concepts that we have been working on this year, which was also talked about at HPE Discover, our flagship conference, is if I had a distributed IT infrastructure that I was trying to manage, can I actually sort of look into what the carbon footprint of my global IT usage is? And not just that, can I actually dive down into different locations? In this particular case, let's actually look into Tokyo. And these are all mocked up data. So, but if let's say you're looking at Tokyo site and so on, what you can actually see is that compared to the global emission factor, Tokyo is actually doing much worse. And then you can even look at some of the reasons why that might be. The average energy efficiency is low, even the energy cost is high, and so on. And then actually even looking at the sources of from where the energy is being drawn, the total carbon emissions are higher as well. So that can actually lead compared to, so what I'm trying to say is that if you can observe these things is what you can use for the insights to make things do better. Then you can even actually sort of do a deeper dive into what the servers are running, what the utilization is. Remember, I was talking about running the infrastructure at the highest utilization or capacity as possible and so on. So you can, but I think the details aside, the observability is key to how well you can control the IT and the infrastructure that there is, right? So once you have the observability, like we were talking about in the dashboard, and the observability for other use cases, sort of moving from what HPE in general has been doing towards more research and collaboration that we are trying to do. So how do you empower the sustainability innovations? I will give you 4 examples and briefly sort of tell you more about that. Primarily in 2 categories, right? One is if you have distributed IT infrastructure, how do you make it more sustainable, right? Energy efficient and such. And then also the second one about how can you leverage the interesting innovation in IT itself for the sustainability and energy efficiency, energy generation and so on. So some of you might have actually seen the recent announcement earlier this year about HPE announcing the Frontier Supercomputer with our partners at Oak Ridge National Lab. This is the first exascale supercomputer. For those of you who don't know exascale, it is 1 billion calculations per second. So there is actually a tongue twister, quintennial calculations per second. And that's what it does. To put it in sort of context and perspective, this supercomputer is more computes faster than the next 7 supercomputers combined, right? With roughly 9,000 compute nodes. With each compute node, there are 4 GPUs. So times 4, about 37,000 GPUs, networking of 92 miles and so on. And then be able to actually do what is called 1.1 exaflops per second. It puts us as the the fastest supercomputer ever built and provisioned, right? But to actually sort of say that this is the fastest, one of the focus also, and one of the cool things about this computer also is that we are not only on the top 500 list, we are on the #1 on the top green 500 list also. By green, basically how many gigaflops can you actually do on for per watt, right? For one, so it's actually sort of, again, to put this in perspective, it is, I think, 30% more energy efficient than the previous most energy efficient supercomputer that there was. Right, so you might actually be wondering how and this is how it is actually so energy efficient, and part of it actually comes from the cooling that was earlier done primarily with air, right? A lot of the cooling that Frontier is doing is based on cooling distributed units using liquid water, liquid cooling, and this actually sort of shows how not only we can support chilled water up to 40 degrees Celsius, we also actually support waste heat reuse in in each of these racks, because the Frontier is basically made of 74 of these Cray EX400s combined together, right? So switching gears again, I think, so what are these supercomputers really used for, and what are they trying to do in sort of collaboration with the National Renewable Energy Labs? We have been working on AI Ops, where we are actually using AI to improve the efficiency of these computes, as well as the data centers and the facilities which are running these computes. Right, so I think Janice yesterday talked about the amount of data which is being generated. So if you think about large data centers running supercomputing and things, the number of data points that you are actually sort of getting from these exascale machines is over 10 million data points per second, right? So can you use all that data to do anomaly detection and such, and use predictive tools to improve the energy efficiency as well as the resiliency of these IT infrastructure? Because, and the resiliency is important because you don't want things to sort of fail and then you having to basically sort of redo a lot of that compute and things. So what we are doing here is to use what we call AI Ops, artificial intelligence operations, to be able to do anomaly detection, the analytics and things. And then remember the loop, the ability loop that I was talking to you about the observability and controllability. So using a lot of that analytics and then feeding that into sort of the predictive maintenance, or being able to actually detect what is happening so that you can improve the performance of these systems. These are some pictures of what that looks like. The other use case, and now sort of switching from more IT sustainability to IT for sustainability, right? Sorry, moving from sustainable IT to IT for sustainability. We have been, labs has been partnering with the Carnegie Clean Energy. So if you, right, being on Pacific coast, when you have taken a walk to the Pacific Ocean, you probably have seen that the ocean energy and the wave energy is there, and the energy coming to our shores is 5 times the total energy requirement of the planet today, right? And a lot of that energy is untapped. Carnegie Clean Energy, our partner from Australia, has been working on what are called the wave energy converters, to take these CETO converters and then be able to actually convert them into energy and the actuators and things like that. So the interesting aspect of this is that if you think about AI and the work in AI which was done earlier, with respect to a lot of static data, building static models and things like that, won't actually be very useful for the kind of learning that is required for improving the efficiency of that energy capture. Right, so we are actually sort of working with them using multi-agent reinforcement learning, where you can take the data from these wave sensors and then train the reinforcement learning controller, and then be able to actually sort of improve the capture of the wave energy, which is coming sort of laterally up, down, and so on, to be able to improve this using our multi-agent reinforcement learning controller. We have been able to actually improve the efficiency 3 times. And most recently, last month, the work that we actually sort of did, my colleagues at HP Labs, Hewlett Packard Labs, got the best application award winner. You can actually go and read more about this work as well if you need more details, or talk to me later. So I think with that, given the time, I wanted to sort of just sort of put the various examples and things that I talk about and say, look, how does this all stack up, right? We talked about the sustainability dashboard, about monitoring the IT infrastructure. You can sort of go beyond IT and start including the real estate and the enterprise and the cities and things also on top of that. Then in terms of IT expanding from not just these data centers, but beyond to the edge, and trying to actually figure out how to use IT across different market verticals, whether it is manufacturing or agriculture, to improve the sustainability. And again, right, the goal of the observability is to be able to do the analysis and be able to extract the insights about what kind of anomaly detection you can do, what the prescriptive advice is, and how to take a lot of this foundational data, which is enterprise specific, to reduce the carbon footprint through analytics, right? And then, of course, combine that with the supply side and demand to be able to figure out where to source the energy from. On the sustainability dashboard, I was talking to you about how we can actually sort of dig into what the emissions from the sources of the energy that are being consumed by the IT infrastructure is. Can we source them from appropriately more renewable energy sources and things, right? So if you want to put things into perspective and where they fall, I think a lot of the work in terms of what we are doing with NREL on AI Ops is more sustainable IT and the sustainability dashboard. And then the rest of it, we are combining the demand and using the analytics to improve, let's say, the energy generation in partnership with Carnegie Clean Energy. That all is what you can actually think of as IT for sustainability. And of course, just like Janice was saying, a lot of this work in terms of observability and data analytics, and then controllability can be used for targeting different verticals, whether that's healthcare and manufacturing. She talked about some agricultural use cases yesterday. So they can actually be applied to different things. And again, I think I will pause here with my sort of notion for saying that you need to be able to observe, to be able to actually control these different aspects and improve the efficiency and leverage IT for sustainability and making the planet much more sustainable and better to live. So, thank you.
Great, yeah, thanks so much. So my question is, how much at Hewlett Packard, how much of this initiative for sustainability comes basically out of a culture of, bleeding heart, do goodness, and how much are the bean counters on board with, right? I mean, this is always the question is do the money crunchers, are they buying into it? And how much of this is driven by that? And how much is just cultural at HP?
So that's actually a very good question. And I think the culture has, so one, I represent HPE, Hewlett Packard Enterprise, not HP, which is the printer and the laptop company. I do use HP laptop, but so I think the culture is very important, right? And I think in Janice's talk yesterday, she talked about how the founders were also wanted to do good and things. That said, I think there are definitely sort of revenue benefits from actually sort of approaching these things. But what we are also trying to do is to actually partner with sort of our collaborators like Carnegie Clean Energy, right? And then going and finding how IT and a lot of the AI stuff that we are doing can be used for that sustainable cause, right? Doing good, but using what we are good at, right? So to answer your question, I think a lot of it has to do with culture and doing good, but at the same time, also realizing that sustainability itself is important and something that all of us should be working on.
Yes, is it on? Yep. Thank you for your presentation. I wonder if your claims about the greenness or the sustainability of these supercomputer machines that you presented to us would look very different if you were to include the energy cost, the energy use, and the greenhouse emissions of the extraction that is required in the mining for all those minerals and metals that are used to make those supercomputer machines. Because it seems from your presentation that the boundary of analysis that you place is around the manufacturing and the use and maybe the upcycling or recycling of these machines, but not in the extraction of the minerals and metals used to make them. So I wonder how the analysis would look different.
Good. So that's actually a very good question too. I think a few things that I can say. There is one, yes, that analysis in terms of being number one on how green each of the compute is based purely on compute, right? But going to your question about the energy generation to be able to actually sort of run these supercomputers. And actually any compute, for example, even my laptop, which is running here, needs energy and so on. I think the sourcing of that energy in some ways is orthogonal to the supercomputer itself, right? So what I want to say is that you can, again, using the for example, the sustainability dashboard that I was saying in Tokyo and what the greenhouse, you can draw those insights and then use that to control where that energy is being sourced from and what the renewable energies and things like that are. Right, so it does not make it less green. There are these other control actions that you can take to make the whole ecosystem sort of greener. Right, and the last aspect of the supply chain and building these supercomputers and things, I think in my first slide with the vantage point of working with these social audits and things, that was important because we are actually looking into the supply side and how sort of from cradle to cradle, as it is called, to be able to actually make the manufacturing of these components and technologies themselves better. So we have not ignored it, and we are working sort of very much along those lines also. So I think being the sort of most energy efficient supercomputer still holds. But there are other things, as you're saying, that can be addressed, but they're independent or orthogonal to what we're trying to do.
Question here.
Yeah.
On the exascale computer, is that water recirculating or is it flowing through? And if it's recirculating, how often do you need to slow down and replace?
That's actually a
And the
good
volume
question.
is really what I'm wondering about.
Yes, so unfortunately, that's not my area of expertise, but if you send me a message, I will be happy to actually get you more details on that. I think there is mix of recirculation and also being able to actually extract the heat out. And we are not the only ones actually using liquid cooling. It's being used in various other deployments as well.
Ever since the Cray.
Yes.
All right, thank you so much. We are running out of time. Tom, do you want to-